Did you know in 2009, 1 out of 12 people had asthma? That's roughly 25 million people.
Asthma, also called bronchial asthma, is a chronic disease that causes narrowing and inflammation in the bronchial tubes from airborne substances such as pollen and dust mites. Other causes or asthma triggers are cold air, physical activity, and strong emotions or stress. Symptoms of asthma are shortness of breath, chest tightness or pain, causing or wheezing attacks, or whistling or wheezing attacks when exhaling. Since asthma has many phenotypes, it is difficult to pinpoint a specific gene. Thanks to scientists at the University of Sao Paulo School of Medicine in Brazil, they were able to find the gene IL1RL1. This gene highlights essential roles for innate immune response pathways that promote T helper 2 cells that are important for immune responses against pathogens. When someone with asthma experiences symptoms from being exposed to a trigger, their smooth rings of muscles in the bronchial tubes contract and become narrow, leading to swelling and mucus production that causes blockage in the airways and making it difficult to breathe. The word asthma originates from the Greek word short of breath. In 2600 BCE, ancient Egyptians mentioned symptoms of shortness of breath and respiratory distress. Hippocrates, an ancient Greek physician, observed this disorder's characteristics and called it asthma. In 100 ACE, Aretius of Cappadocia, another well-known ancient Greek, suggested a remedy to cure asthma, which was drinking a concoction of owl's blood and wine. Unfortunately, there is no cure to asthma, but there are treatments to help people with asthma. These treatments are an inhaler, a nebulizer, or a pill. These anti-inflammatory drugs, especially an inhaler or nebulizer, allows the medicine to go directly into their lungs, reducing the swelling and the mucus production in the airways. The same scientists at the University of Sao Paulo School of Medicine in Brazil performed mice experiments that were successful in reproducing many features of asthma, such as airway inflammation and airway hyperresponsiveness. To achieve this, they had to induce OVA, or ovalbumin, and aeroallergens into the mice. As a result, airway hyperreactivity, goblet cell hyperplasia, and pulmonary eosinophilia were present in the mice model. With this new information, it could help scientists learn more about triggers and genes that include pro-inflammatory mediators like the IL1RL1 gene that we mentioned earlier. With this mice model, it will help future advancement towards today's medical treatment such as inhalers and nebulizers. It will also create more treatment options in the future by the new studies found helping understand the role the respiratory and immune system has on asthma. With these treatment options, it will help my family and many others who suffer every day from asthma and prevent someone from becoming a statistic.